Welcome to today's explainer. When we think about pollution, what's the first thing that pops into your head? Probably big billowing smokestacks, right? Or endless traffic jams, or maybe that massive plastic patch floating out in the ocean. Well, today we're diving into something completely different. We're going to uncover the invisible, physical, environmental cost of our everyday digital habits. 2 to 4%. That's the estimated chunk of all global carbon emissions produced by the global tech industry in 2026. And honestly, here is the real kicker. That's actually more than the entire global airline industry. Crazy, right? Section 1. The invisible pollution problem. We can so easily picture airplanes burning jet fuel or cars pumping out exhaust, but we almost completely ignore the apps on our phones, the websites we scroll through, and the invisible code powering literally all of our devices. It really boils down to a pretty simple equation. A staggering amount of global electricity is just wasted by poorly designed, inefficient code. I mean, we're talking about software that takes 100 steps to do what could easily be done in 10. And wasted computation literally equals wasted electricity, which, you guessed it, equals wasted carbon. It's a massive climate problem, and it's hiding right there in plain sight.
Okay, let's dive right into this. Section 2, where the energy goes.
So let's physically track down where all this digital energy actually goes the second you tap your screen. We can methodically trace the physical journey of a super simple action, like, say, watching a YouTube video or just typing in a search query. It all starts at step 1, your device. But your request definitely doesn't end there. Step 2, it travels miles and miles to distributed servers sitting in massive data center warehouses around the globe, warehouses that never, ever sleep. Step 3, all those servers generate an immense amount of heat, which requires heavy-duty cooling systems just to keep the whole place from melting down. And finally, step 4, all of this draws massive power from a physical electricity grid, a grid which, unfortunately, is still largely powered by burning fossil fuels. To make this a bit more visceral, just consider this one statistic. A single ChatGPT conversation of, say, 20 to 50 questions consumes about half a liter of water. That's like a standard bottle of water, just evaporated, gone. And that's just to cool the data centers running the AI model. Your digital conversation literally drinks water. How wild is that? So, what does this wasteful code actually look like under the hood? Section 3. Why code is wasteful. Why is the software we use every single day so incredibly inefficient? Well, we've got 3 main culprits here. First up, unoptimized loops. Imagine searching a list of 100 million names one by one instead of using a smart algorithm. That burns massive CPU cycles for absolutely zero reason. Second, overloaded web pages. You know, the ones packed with heavy tracking scripts and a million features nobody ever clicks. And third, zombie servers. These are computers just running at 100% capacity all night long for 0 users, mostly just because it was easier than setting up autoscaling. And look, these aren't malicious choices, right? They're really just the result of a historical tech culture that almost always prioritized development speed and convenience over energy efficiency. To put that digital bloat into perspective, the average web page in 2026 is over 2 megabytes in size. For context, that is actually larger than the entire original Doom video game. The whole game. Modern web pages are just incredibly bloated with uncompressed images and unused JavaScript frameworks. And they're consuming energy at every single step of the journey, on the server, in transit, and right there on your screen. Section 4, the green coding solution. But hey, it's not all doom and gloom. Enter the heroes of our story, the green coding movement. These are developers on a mission to minimize energy consumption with every single line of code they write. And this brilliantly illustrates their point. Did you know that just choosing the right programming language for a massive application can dramatically reduce its carbon footprint? Check this out. For the exact same computational task, if the C language uses just 1 unit of energy, JavaScript uses 4 and Python uses a staggering 76 units. No way, right? 76 times more energy. Green coding also heavily focuses on optimizing data and really designing for efficiency. Every time you compress data or cache it, you're moving fewer bytes and therefore saving energy. Netflix famously did exactly this with their video encoding pipeline. They created better compression that transferred way less data, which ended up saving them millions in server costs and drastically cutting their emissions in one brilliant move. Talk about a win-win. It also means intentionally cutting out unused features. It's about pausing and asking if a digital feature truly provides enough human value to justify its real-world energy cost. Then there's this absolutely fascinating concept called carbon-aware computing. This basically means intelligently scheduling heavy computations for times when the electricity grid is actually running on clean energy, like solar or wind. Think of it like, well, like waiting for a sunny day to do your laundry if you have solar panels on your roof, but applied at a massive global data center scale.
Section 5, the AI energy wildcard.
Okay, so the need for green coding just got drastically more urgent. Why? Because AI is the most energy-hungry software in human history. A single ChatGPT query uses roughly 10 times more energy than a standard Google search. 10 times. Every time you casually ask a chatbot to summarize a document, it triggers this unprecedented cascade of computation and energy consumption that literally would have seemed completely absurd just 5 years ago.
And that is just using the AI. Training it, that's another story entirely. Get this. GPT-4's initial training run was estimated to consume over 50 gigawatt hours of electricity. Let me pause there. That is enough power to run roughly 5,000 American homes for an entire year, just for one single training run.
But let's pivot back to a more hopeful tone, because the industry is actively using AI to solve its own massive problem. For example, Google used its DeepMind AI to figure out the absolute most efficient way to manage temperatures, and they ended up cutting their data center cooling costs by a massive 40%. We're also seeing this huge trend called model distillation. That's where you use a giant, energy-hungry AI model to train a much smaller, highly efficient one that performs nearly as well. It's essentially paving the way for green AI. So, the crucial point is, what's next? Section 6, what we can do. So, how do we actually fix this whole shebang? What actionable steps can the tech industry and everyday users like us take right now? Well, for developers, amazing new tools now exist to actively measure a code's exact carbon footprint. For companies, honestly, it's a total win-win. Writing efficient code lowers their cloud bills and electricity costs, proving that sustainability perfectly aligns with profitability. For the industry at large, strict new EU efficiency regulations are forcing data centers to finally step up and adapt. And for us, the everyday users, simply closing those dozens of unused browser tabs and deleting old files from cloud storage actually makes a real difference. Tiny actions multiplied by billions of global users have a massive cumulative impact. As we wrap up, I want to leave you with this incredibly powerful thought. We really need to completely deconstruct the cloud metaphor. As the quote says, the cloud is not a cloud. It never was. The internet is not some ethereal, weightless magic floating up in the sky. It is a massive, physical machine made of concrete, steel, silicon, and fossil fuels. Which brings us to our final, provocative question to end today's explainer. Every line of code has a carbon footprint. How heavy is yours? Even if you aren't a developer, every time you open an app or stream a high-definition video, a physical computer in a warehouse you will never see spins up, burning real energy just to serve you. I really hope this explainer has permanently shifted your perspective on the very physical weight of our digital actions. Keep questioning the world around you, and I'll catch you next time.